I'd just preface this talk by saying that when I was working for Newmont, we had a brainstorming session one time, and it was all about what could change the industry. And one of the things that put forward was being able to do gold by XRF. And just out of interest, how many people here are gold explorers? How many people would like to be doing gold by XRF? Yeah, that ability to do assays overnight. Anyway, the follow-up, 10 years later, I was in a bar in Toronto, PDAC, early hours of the morning, wines of the world, and someone let slip to me that CSIRO in Perth had invented this method that allows you to do sub 10 ppb gold using portable XRF. I went, whoa, that's the holy grail. Contacted a business mate, and he said, his first reaction was, we should try and get that and commercialize it. And I went, thought about it for a nanosecond and went, yep, that's fantastic. The guy in the front seat here is the inventor, Mel Linton. Known him for a long time, but I sent him emails, he didn't respond. Eventually went through expressions of interest. Eventually now our company, Portable PPB, has the global rights to Detector, the CSIRO invention. What I'm going to do is take you through very quickly through where it's at, the plans for taking it forward and bringing it out to industry, which at this stage we're aiming for mid-2020. We're working with sponsors, but we'll take it through. I'll show you how the data works and what stage we're at. Essentially, gold exploration is very slow. You go and collect samples and you're waiting all the time. Quite often it's many companies actually work on a bit of ground before it's actually the discovery's made. And I'm sure we've all done that. We've gone second, third, fourth, fifth, sometimes 6 companies before the tier 1 discovery is made. And that's because the gold deposit can be out under cover or something like that. It takes a long time, which means that we're a poor industry to invest in. And remembering that we compete against telcos and banks and others for money. If we can improve that, hopefully more money will come in and we will get away from these chronic boom-bust cycles that we all suffer from. It costs money. Every day, a junior company, $1 million a year to run a junior company by the time you've got the MD, the CFO, etc. $3,000 a day to keep the doors open. Every day we're waiting for assays, that's money down the drain. We're not advancing. We're looking for an element off the periodic table. We need gold assays. So, of course, the quicker we can make a discovery, the better the shareholder return. And the faster we can make that return, the better it is for everyone and more people put money back into the industry. Great, we all have jobs. So, unfortunately, and Mel came up with this one about battleships. Exploration can be a bit like battleships. You've got a limited number of prospects you can check in the time you're given. You're working for a major company, you've done the project generation, you've taken out the bit of ground, and usually senior management has an attention span of about 3 years. If you don't find it 3 years, forget it. It's farmed out because someone else has come in the door, given them a sales pitch, and they're ready to go with the next one. So, unfortunately, you have limited shots you can fire. And when you're waiting for assays, that really limits the number of shots you can have. And sometimes it even happens that these shots are positive, like red ones here, and you're onto something, but then a boom-bust cycle's happened, and the money dries up. Another number of companies I've consulted into over the years, and you can look at the data set, you go, hey, how come no one's followed up on that? Oh, the takeover happened, and so-and-so was let go. And the data then got sucked into the database, and no one actually followed up on it. How much better would it be if you had the assays there that night or the next night? Then that wouldn't happen, would it? Someone's there that's enthusiastic, engaged with it. So that's why in those early hours in Toronto, I was going, wow, we could do this and that, it would be fantastic. I showed you that example from Burkina Faso with Boromo Gold. We took 2.5 months to do that program, stage program, 800 by 80 meter soils, do the follow-up, do the auger. With this technique, we could have done that in 2 weeks. And we'd be on to our next prospect, on our next prospect, and our next prospect. So what's the prospect? I've done it for nickel. This is an example, it's on YouTube. There's a presentation I gave at PDAC in 2015 with the last company I worked for, Griffin Minerals, where we did stream sediments, we picked up a nickel and copper anomaly, and then it was a matter then of going back and doing follow-up. I was given $20,000. We ended up doing 2,016 soil samples. On the 17th day, I had the last nickel assay back for using pXRF. We didn't dry them, we just sieved them to -2 millimeter in the field, put them in the cups and got a reading. The results came back below. 1.6 kilometre long anomaly, 0.6% nickel, 100 by 20 metre spacings, all done in 17 days. I'd love to be doing that for gold. Again, that was going through my mind when I heard, despite it being on the second bottle of red wine, I think it was going through my mind that, wow, we could do this, this would be a game changer. This is what I want to be doing. And do all that in regular terrain context. So, Detectors is the technique, the CSIRO technique. It's patent pending. Gold results less than 10 ppb, less than 24 hours. Use a consumable. and some cloud-based software. It's expected to work across all exploration samples. Can be applied from a field remote site using portable XRF. I think it's going to lead to continuous adaptive geochem sampling. If it all goes to plan, I'll take you through what that is. And its greatest impact, of course, is going to be in remote areas away from labs where you're having to drive your samples out. So Mel was the inventor, he's done all the chemistry side of it, and then there's also a software aspect as well, which has been done by Andrew Rogers. And then Wayne overall has been the business manager. He's the guy we've been dealing with on the expressions of interest and putting the place in. But essentially, you know, it's this snail moving across the screen. It's waiting for assays all the time. You collect a stream sediment, send them away, wait for it to come back again. You collect your soils, you do your phase, you then wait for the assays to come back. If you're working in an environment where there's a wet season, or if it's working up in the tundra where you're waiting a very limited field season, how much better would it be to be able to get the assays back whilst you're out there in the field, and then to be able to do that follow-up? So the gold industry, of course, has been using XRF for a while, but we've only been using it for pathfinders trace elements. And so we're looking for one element off the periodic table, preferably gold. It'd be nice to be analysing for those. The problem with gold's been it's suffered from interferences, but it's also been the detection limit's been too high, and it relates to the spotty nature of the gold within the samples. So CSRO set out to resolve that. Mel had an aha moment when he was on holidays, came back and it started experimenting, and then took it on from there. And after a series of experimenting, came up with what's now Detector, or the version at the moment. It's had limited field trials. I'd say that there's lots of many known unknowns. We've got issues like managing with different XRF models, and then getting all the QA, QC protocols in place. As part of the development work we're doing, we're putting all those into place. How does it work? Essentially, you have a bottle, 250 grams of sample goes in. I was hoping when I heard about it, by the way, that it was going to be instantaneous, but of course it's not quite that easy. But essentially, the way it works, 250 grams of sample goes into a bottle. There's something which we're calling a widget goes in the bottle. Add water, leave it there for a while. Take one component out of the widget out of the bottle, dry it, put it in front of the XRF window, and then there's some special mass, which was the other phase of it, which then ends up giving you the result. And then with that, you can collect, test, and decide. Here are some of the results running CRMs. So current level is light blue is above a gram, purples are below a gram. Current threshold 2 to 5 ppm, so it's order of magnitude lower. To me, that's highly encouraging. It's not fail-safe, but it's highly encouraging. It shows that it's on the right track. The other one is where Mel's taken solutions and applied one component of the widget to it. And now this is working down, and it's showing you that from 10 ppb down to 1 ppb, it's also working. What this is telling me is that the maths is right. It's able to take the signal from the XRF and give me the levels I'd want for a stream sediment. Encouraging. We've still got to prove that it works on stream sediments. Some of the work that's been done is go out in the field. There was a prospect that Mel had access to, go out in the field, collected soil samples over the top of an auger anomaly. So back to front, different way to how I do it, but it's still, you've got gold there, let's go and see where they can find it. Load up the bottles out there in the field. Next day the assays come back. The green line there is the standard auger results. The red and the blues are the soils over the top of it. It's all relative difference, but it's told me that you've found the same prospect. It's found where I want to go and put the auger hole in. So that's pretty good. So the stage it's at, patent pending, setting about now doing global test work and building it all up. Expression of interest was gone through. Principles of PPB, we've all got global experience, etc., and been involved in commercial startups. Another person involved is Peter Williams, who was involved with HiSice and other technologies, so we've got that side. And Mel now has left CSRO and joined us as Chief Technology Officer to continue the work that he started. And we're now getting ready to gear it up and take it out to the global gold industry. Commencing extensive lab and field trials ahead of commercial release, hopefully by mid-2020. And we're receiving support from sponsors, which includes majors, mid-tiers and juniors, and using an innovative sort of sponsor scheme. Been around the world, secured samples from all these different areas. It's all about trying to test and get that test work done in the different areas. It'd be no point just doing the test work here in WA And then even though the regolith is the same in West Africa, people in West Africa go, oh, yeah, but we're slightly different. Our rocks are different. Our regolith is different. How do you know it's going to work? Or if you're down in the Andes, if you're in the southern part of West Africa and did the work, say, in Ghana or Suriname, in Ghana or Cote d'Ivoire, we could run it there in the tropical rainforest. And then people over the pond, as they call it, the Atlantic, over in Guyana, she will go, but it's different here. How do you know it works here? So instead we've gone around, secured samples. Initially they're coming into us, into Perth, for which we've got a 500 metre square warehouse down in Canning Vale. We're setting it up. We've got a big stack of Aureus standards there as part of the test work, and we're going to run comparative work here, send off part of the sample off to a lab. So we've got direct lab comparison against a whole range of samples, and then set about going out and doing the field work after that. And as I say, it's about testing the different samples, so a whole range of different sample media, and then also covering different regolith states, whether it's weathered or fresh, and then also covering the various styles of mineralization, whether it's orogenic, porphyry, IOCG, etc. So we're running through that. At this point, I'll just say that we call the company Portable PPB, not PPB Gold. It's because with time, we expect widget 2 and widget 3 and maybe widget 4 will come into play, which will give us different elements at a low level. I'm glad to say that we've secured a lot of samples, but all of it's going to be, initially we'll be doing a lot of cross-checks against traditional lab analysis at a very high quality lab here in Perth. So in summary, time's not kind to gold companies. It's very costly to investors. I think gold by pXRF at meaningful low levels is now possible almost anywhere. We just need to do a bit more test work on it. I think it's going to help change the way that we can explore or lead to continuous exploration and adaptive sampling programs, which then all feeds back. It feels to me like it's bringing together my career. It means then we've got to put stuff back in regolith terrain context and be looking at the values in the right way. We're aiming to have it fully, it's all about setting up fit for purpose field trials, again, regolith terrain context, oxidation states, etc. And aiming to have it fully tested and out by 2020. Sponsors who get on board with us, which we've got 7 so far, they're getting short and longer term benefits by getting involved, and they will get early access to the technology as well as getting samples tested on their ground. So when it is eventually released, they get a jump start on everyone else, and they will also have gone through that test period with us, but we've got a limited number of sponsorship places. So that's where we're at. Thank you.